Still writing endless automation scripts? Let's change that. No more boilerplate, no more setup headaches. Today, we'll see how to automate your entire testing workflow using Playwright MCP and GitHub Copilot inside VS Code without writing a single line of test code manually. We'll build a full BDD framework, auto-generate locators, run tests, and sync results to your test management tool, all powered by AI. Let's dive in.
Hello. In the previous session, we saw how to use Playwright MCP for manual testing. Now we're going to see how to use Playwright MCP for automation testing. What we'll do is take the same test cases we generated in the previous session and run automation testing on them using Playwright MCP. I'll reuse the setup we already created earlier, GitHub Copilot and Playwright MCP, to perform the automation testing. As you can see here, Playwright MCP is installed and the GitHub Copilot chat panel is open. Using different LLM agents there, we're going to start automation testing. I've opened an automation testing directory. I've copied over the tests we generated during manual testing, and I've also created a few files to store the prompts I'm going to send, so we can just copy-paste them quickly and save time. Let's start with the automation testing. First, for automation testing, we need a proper project structure. We'll generate a Cucumber plus Playwright project. We'll even generate the project structure via the LLM agent itself. I'll copy the required prompt from this file, paste it here, and send. It asks me to select a workspace folder. I select the automation folder. Any directories or files it creates will be generated inside this automation directory. While that's running, here's the structure we're aiming for. Cucumber BDD for behavior-driven testing. Test runners for execution and reporting. Page object model for structure and reusable page elements. Some utilities and configuration management for flexibility. The most important file is pom.xml. This Maven configuration manages project dependencies, build lifecycle, and plugins. All required dependencies are added there. It then generates automation folders like features, runner, step definitions, etc. Let's explore the structure. Under src, test, Java, for example, in a package like automation, it generates directories such as hooks and pages. Pages, page object model classes that define web elements and related actions for each page. Util, utility classes for browser setup, weights, configuration reading, screenshots, and other reusable functions. Runner, the Cucumber runner class that defines which feature files to execute and how reports are generated. Step definitions, implementations of Cucumber steps that connect Gherkin steps to actual automation code. In resources, it places configuration files, for example, timeouts and other settings. In features, it creates a sample feature file. In test data, it stores any execution time test data. So it has generated the entire Cucumber BDD framework for us. In chat, it also explains the project structure, what was created and why. So we understand how to update which files when doing project automation testing. It lists the features, runners, commands for test execution, report generation config, etc. Now the framework is ready for use. We can start adding our own feature files and begin actual automation testing. Let's close these for now. We'll take the test cases we created during manual testing and convert them into our BDD format, then execute. I'll go to the instructions prompts and use the feature file generation prompt. The prompt says, generate feature files by following the instructions attached. Convert the manual test cases into BDD format. Along with some requirements, we'll attach our manual test cases in the context and send the prompt. Within a few seconds, it generates the feature file, say, add underscore to cart.feature, with all steps written in Gherkin. For example, given user navigates to the demo site, followed by verification steps. We'll save this file. Next, let's create the corresponding step definitions and page objects for this feature. It generates page objects, for example, Demo Blaze, Homepage, Product Page, Cart Page, and writes the required logic. In step definitions, it maps the Gherkin steps to code. The BDD scenarios are now ready for execution, formatted exactly as requested. However, there's one issue. The 3 generated page files have some locators added by assumption. We're not sure they're exact. Incorrect locators could cause failures. Traditionally, to get a specific locator, for example for Samsung Galaxy S6, we'd open the URL, inspect, and write verify the selector manually. This is time-consuming and error-prone. To avoid that, we'll use Playwright MCP to fetch exact locators automatically. First, confirm Playwright MCP is running. I'll restart to be safe. Our goal: extract exact locators for the pages and replace them in our code. I'll send a prompt like extract exact locators required for the page and replace them by navigating the site. We'll provide the feature file as reference, so it finds only the required locators and replaces them in our page objects. MCP takes control of the browser, launches the site, explores it, and gathers the DOM structure. With full DOM access, it can reliably discover exact selectors. It then updates all page objects with the precise locators it found. The red highlights show old, assumed locators. The new ones replace them. With these accurate locators, our tests won't fail due to selector issues. The framework is now equipped with real, stable locators for reliable automation. Now the feature file is ready to run. We execute with a clean build or test. It loads properties, launches the browser, starts execution, clicks a product, adds it to cart, asserts, and completes. The tests pass. The run finishes successfully. After execution, we want a report. The build creates a target or folder containing a Cucumber report or directory with cucumber.html and cucumber.json. Open cucumber.html in the browser. To view which test cases passed, timings, and details, the cucumber.json contains step-level execution data. We'll use this cucumber.json to create an automation execution in our test management tool with a single command. From the prompt file, I'll copy the execution creation command, paste it into chat, and attach the required files, cucumber.json 4-step statuses, and mcep.json for project name or values required by the tool. Send the single-line instruction. It calls Create Automation Execution. After allowing, we see Automation Execution created successfully. To verify, we use the ID, for example, T005. Open the execution dashboard in the Test Management tool and check that T005 exists. It shows 1 test executed, 1 passed, with 14 steps all passed. The cucumber.json data has been mapped into the tool. Click into Executed Test to view details. Each step shows actual result, matching expected. All 14 steps passed. So with a single command, we created and populated the automation execution in the Test Management tool from our automated run. That's the full flow of how to use Playwright MCP for automation testing. From this session, we learned that with Playwright MCP, we take a big step toward intelligent automation. It's not just about running test cases. It's about understanding and generating the entire automation framework. With one simple prompt at the start, we generated the complete project structure, from page objects to test code. Within a minute, using AI, we identified accurate, stable locators automatically, reducing maintenance effort. We generated a README file so new team members can quickly grasp the framework and logic. This integration truly bridges the gap between manual and automation testing, allowing professionals to focus on strategy, quality, and innovation, while AI handles the repetitive parts. The future of testing isn't just automation, it's intelligent automation powered by AI Playwright MCP. Thank you.
So, you've seen the power. Exact locators extracted instantly, and a complete ready-to-run Playwright project structure generated from a single line of natural language. If this accelerated approach to test automation excites you, give us a like and subscribe to join our community of advanced QA engineers. Ready to integrate this into your workflow? All the resources you need are in the description below. Go automate smarter, not harder. See you next time.